So today's lesson 9.1 is over the domain and range, minimum, maximum, just some different things with functions and with their graphs. Today I will say, I know I've said this before, but it still applies with this. If you are not good at math, this is what you have to be good at, because there's not a lot of math today. It's more remembering where things are and what numbers to pull from. But like my calculator, I'm not going to use my calculator in all today or do any mental math. Again, it's more, I guess you could say vocab, but knowing what things are and what things mean, and there's kind of just a lot of it today. So I'm not saying today's easy. I'm more just saying that today is not as mathy as we've seen in the past. First off, a function is a math phrase that you'll put in a number x and you'll get out only one number y. And that's what we're going to talk about tomorrow a lot. But essentially, a function is if you put one input in, you get exactly one output. So if I put a 4 into a function, I'm going to get out a 10. You can never have one where you put in a 4 and you get a 10 sometimes, but you get a 5 sometimes. That's not a function. That would be terrible as far as math goes. So again, we'll talk about that a little bit more tomorrow. But we are going to start looking at all this information, the domain, range, maximum, minimum, where it's increasing, where it's decreasing. We're going to look at it from this graph. So there's two types of graphs you'll see. One that looks like this, where everything's straight lines and has definite endpoints. And you'll also see ones that look more like the functions that we have graphed before, where there's curves and they kind of continue on different places. We'll look at all that today. So first off, the domain and range. The domain is talking about what x values, once that eventually scrolls up, what x values are covered by your graph. So what x values have a point that's on your function. So for instance, this x value has a point right here. This x value has a point over here. This x value over here doesn't have any points on my graph. So we want to know what x values are on, or what x values are on our function. The range is the y values. So what y values are on the function. So I have thought about several different ways to explain this, but I think what I've decided, the easiest way to look at this, if it doesn't make sense to you, but for some of you, if you need this, I draw a box around this graph and I make it as small as I can. Whoops, I'll have to start over, I guess. I draw this box as small as I can get that goes across my whole graph. So I can't make it any smaller without cutting off my graph. I don't want to make it any bigger because I want it as small as possible. So your domain is the number on the left and your highest number that goes to on the right. So over here at this 7. 5, the 7. Your domain is between -5 and 7, or your graph, your function is in between -5 and 7. The way you represent that with a graph, you put your, since it's the domain, it's the x value, so you put your x in the middle, and then you always point your inequalities to the left, and they are always equal to. That part of that equation or that answer is always going to be there. You always put your lowest number on the left, your highest number on the right, and you always, again, for your range, it's going to be a y instead of an x. So you always have your variable, and then you have the inequalities pointing to the left with the equal to line with it. Every single time you're going to do that. And again, you do that every single time you want to say the word in between. So it's between, your graph is in between -5 and +7. With your range, it's the same exact way. Your range is now talking about the y value, so it went from -2 to 4, so -2, +4. My y is now in the middle. Your range is always your y values. And your inequalities, you always point to the left. Again, you can always do that every single time. And that's what I mean where, yes, maybe I should be a better teacher and really explain what that means. Actually, I can. But really, if you just memorize that, you're good to go. What it actually means is part your inequality is saying y is greater than -2, so your y is everything bigger than -2. And this part is saying y is less than or equal than +4, so that means it's below 4. So again, that just means it's in between. When I talk about the maximum or minimum, we are always talking about the y value. And we talked about this a little bit when we talked about quadratics, and we talked about like what's the maximum height that the ball went after you kicked it off of a building or whatever. Well, the maximum height is how high it went on your graph. So again, when we talk about max and min, we're talking about the highest your graph is, which was 4, and the minimum is the lowest your graph is, which ended up as -2. That's always the y value. Your maximum, the minimum, always your y value. Now the next thing, again, you'll learn more about this a little bit tomorrow. But for this one, if I say g of a number, that number is the input. So that's plugging into your function. We don't have a function, we just have the graph. So if they say g of -2, that means your x is -2. Where's your graph? Where x is -2, that's right here. That's up at positive. -2 is +1. G of 1, again, that means your x is 1. That's also 1. G of 4, that is up all the way up here. And G of 6 is right here, crosses at 0. Now I could have asked any of those, G of 2, G of 3, any of those I could do. And it kind of makes sense because you guys have seen this before where we talk about f of x or g of x. Well, instead they take the x and they put in a 2 or a 1 or a 3. Number 5, then it says, where is g of x increasing? And I should have pointed this out, but g of x, I labeled this graph g of x. So every time I talk about g of x, that's what I'm talking about. Where is it increasing? Now, when I talk about increasing and decreasing, what I mean is when you read a graph, you go from left to right, just like you read a book. Left to right. So when you're going from left to right, if you want to like drag your pencil across, if it goes down, it's decreasing. So if I say, where is it increasing? Right here at 1, it starts increasing and it stops at 4. And we're talking about the x values. So again, 1 and 4, and it's just like we talked about with domain and range. If you're going to say it's increasing between 1 and 4, that's 1 less than or equal to x, less than or equal to 4. Decreasing is between 4 and 7. You guys can go ahead and leave. We'll talk about this when we get back. That's close. So again, number 5, if you just want to follow along with your pencil, again, as you go left to right, as soon as it starts going up, that's increasing, and then as soon as it starts going down, that's decreasing. And you can have more than one spot. If there's more than one spot that's increasing, you just write it down twice. And again, it's that same rule that I said before, where if it's between two numbers, you put your lower number on the left, your higher number on the right, and then your variable, your x or your y, goes in the middle. And both inequalities point to the left. For the increasing, decreasing, it's always your x value. Because again, you're going from left to right, so you're listing what x values it's going up and what x values it's going down. So number 6 is between 4 and 7, because that's where it starts coming downward here. Last but not least, where are the zeros? We talked about this before when we talked about quadratics. They can obviously have 1 0, 2 zeros, 10 zeros, whatever. This one has 1 0 at 6, because that's where it crosses the x-axis. So again, if I ask for the zeros or the solutions, I'm asking where it crosses the x-axis. So go ahead, do this one on your own real quick. Again, with increasing, make sure you realize, at least with increasing, there's 2 separate intervals you'll do. I'll give you guys a little bit to do this, then I'll give you those answers. Up there, again, domain is always the x values, the range is always your y values. If drawing that box helps you, again, I think that's a pretty good idea because, like I said, it's just whatever x values your functions pertains to. And then same thing with the y values. So be careful with that. Max min is the y values up and down. And then where's it increasing? Again, it's increasing right here between -2 and 1. And it's increasing right here between 5 and 8. And where is it decreasing? It is decreasing in between those, between 1 and 5. Oh, I put 4. Sorry. Apologies. between 1 and 5. And then the zeros or crosses is at 3 and 7. Just make sure you don't put those in parentheses. That is not an ordered pair. 3, 7 is like way up here is an ordered pair. That has nothing to do with this. So make sure you do not put parentheses over there. Any questions on those before we move on? All right, we're doing the exact same thing. The only difference is now we have more of a continuous graph where it's a little bit more of curves and flows. It looks a lot more like if you just graph like a normal function. This graph we're calling g of x. So the biggest thing, the domain range. So the domain, there's a couple of ways you can write this, but the important thing to realize is that notice how this arrow is going down. Notice it's not going straight down, right? If it's not going straight vertically down, then it means it's always going to be going to the left a little bit. It might take like negative 10. It might be down, way down like negative 100,000. Creep over there. So as you go to infinity, this line, again, it's going to take a while, but it's going to creep over here and keep going forever, never, 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 never. So your domain goes from negative infinity on this side, and then same thing on the other side. It takes a while, but it'll eventually, it never stops going to the right. So it goes from negative infinity to positive infinity. So there's two ways to write this. Is to put all real numbers and use the little symbol or it's a capital R with the 2 downward strokes. All real numbers. Another way to do it though, like me, I like to do all problems the exact same. What I've done is I put the lowest number, I put the highest number, and I put my x with my inequalities. That's absolutely fine. Your answer might look a little bit different if it's multiple choice, but if you have that, at least then you can kind of have some more options. You can kind of look to see what it is. But again, if it's not multiple choice and you put that, I will give you points because, again, that's not necessarily like the quickest, easiest way to write it, but you're absolutely right. It goes from negative infinity to positive infinity. A little bit easier to look at because it's a little bit more obvious that in the y direction it goes forever, never, never, and goes down. So it also starts at negative infinity, but then it doesn't go up, it goes up to 1. That's all the higher it goes. So again, there's two ways to write this. One way is to say it goes from negative infinity is the lowest, 1 is the highest. I'm talking about my y values now because it's the range. You could do it that way. Or the other option is you could just say y is less than or equal to 1. It's the same thing. If I say what's the range, all the numbers less than 1, that's the same thing as saying negative infinity and 1. It's all the same. So I don't care which way you do that. Again, it's kind of nice to do the other way because it's shorter. On multiple choice, I will probably put that other way because it makes it's a little bit more acceptable mathematical notation-wise. But the other way, again, it's perfectly clear. I know what you're talking about, and that's kind of the main thing I look for. Then the other ones are the same. G of 1 is 0. This one ends up being kind of unique, but that's okay. G of 2 is also 0, and G of 4 is also 0. There wasn't any other ones that worked out really nice and evenly without decimals, so those are the only 3 I could go with. 1, that's as high as it goes. Your minimum is negative infinity. Now, I probably won't. I'll have to check, but I don't think I asked you for the minimum if it goes to negative infinity. Don't hold me to that. I'm not sure. I'd have to check. But that's what I would put. If I asked for the minimum, I would say it's negative infinity. Now, you do not have to wrap your brain over this next thing. I just wanted to make sure I mentioned it because it is something it's nice to know, but I'm not really going to like beat it into the ground. I probably won't talk about it after this. Actually, that said, it would be a good extra credit question since I'm going to talk about it a little bit. Local maximum and minimum. It would be a maximum part of the graph. Local maximum is the same as your actual maximum. This one and this one, those are both, I mean, they both go up to 1. But your local minimum would be this one down here because, again, it's not the whole minimum of the graph. The graph goes way lower than that. But just for that section, just for that little swoop in the middle, that is the lowest for that part. So that's what it's talking about with local maximum, minimum. Again, I will not put that on the test or a quiz. I think that someone brought that up, and I felt bad that I didn't talk about it. So that's why I put it in there to talk about it real quick. And last but not least, or I guess, sorry, there's 2 more things. Increasing and decreasing. Again, it's the same exact pattern we just did. The only difference is I'm going to help you a little bit because here's the deal, and I worked really hard for this. It's really hard to get a problem that works out with nice whole numbers for all of these. As soon as I make these whole numbers down here, then all of a sudden that changes your domain and range to be decimals. So for me, I changed that, or rather, since it's left it where it's more of a multiple choice idea. On your win exit ticket, there is one like this that I try to put the instructions very clearly. But on the test, you have one like this that is not multiple choice. Those are the ones that are called multiple response, where you can have one answer, two answers, three or four answers. And that's how this question looks like on the test. It'll say increasing. You have multiple different ones you can pick from. Maybe it's all of them. I don't know. This one says circle the increasing, put a box around the decreasing. So the increasing is where it's going up. So again, you start at your left. So it goes up to 1.4. Clean this up. There we go. Up to this part, which is about 1.4. That's where it's increasing. And then it decreases till it gets to about in the middle. So yeah, 2.5. That's not bad. Whoops. Sorry, that's supposed to be box. That's where it's decreasing. Then it increases again. So between 2.5 and 3.6. Again, maybe that's not exact, but that's approximately. And then it decreases everything that's bigger than 3.6. So everything between 3.6 and infinity, that's where it's increasing. Now again, since there are decimals like that, I didn't want to make one that you have to do your own, so I gave you those options. It's going to be the same thing on the test, where if it ends up being decimals and not nice, even whole numbers, I'm going to give you options like that. Last but not least, where are the zeros to this? Again, everywhere we have 1, 2, 3, 4 of them, and they are at 1, 2, 3, and 4. If we go on to the UDO section for the next one, I'm going to do the domain and range with you guys because this one's a little bit interesting. The domain, again, if you look on this side, the arrow is going down, but again, it's not going straight down. So it might take a while, but eventually it does go to negative infinity on the left. And same thing with this one. It's not going straight up, so eventually it works its way to positive infinity. So the domain is all real numbers. However, with this one, the range is also all real numbers, and I think this is more obvious. It starts down here. It's going down from negative infinity. Over here, it's going up to positive infinity, so your range is also all real numbers. Other than that, the other ones you should be able to answer on your own. So answer those on your own. I'll put the answers up here in a second. My answers are up there if you want to double check. They're supposed to be up there. One set up. There we go. So if I would scroll down soon, but that's okay. Anyway, if you have any questions, let me know. Tomorrow's lesson is another one that I don't think it's similar to this, where there's not a lot of math stuff that's going on, but there's a lot of stuff to memorize.